still, everybody. My name's Mike Brown. Again, I started my presentation last time saying that some of you in the room will know me and had hopefully the pleasure of having some conversations with me before. But I am one of the directors at Onfab, and we provide flexible isolator solutions for many different handling techniques and tech requirements. And we're all about getting you high potent ready. Today, I'm going to have a conversation about the future of processing high potent molecules, okay? We'll have a look at what Onfab does, where we develop solutions for, and where we position ourselves within the market. And then we'll go on to what the future is, or what I believe the future is for high containment moving forward, specifically looking at sort of the ADC sector and where we apply our isolation solutions down into sort of nanogram and picogram levels of containment performance. Okay, so let's see if this works. Okay, so introducing Onfab. From some new sort of recent developments in Onfab over the last few years. So we currently manufacture all of our isolators in the UK and in Spain. There are two manufacturing hubs that we have. We are currently in the process of opening a new manufacturing facility in the US as well. As Onfab grows and develops, we are needing more production and more development space within our business. So we are now looking at onboarding a new facility over in the USA. It will literally look after the US market for us, which is a growing market. And what we touch on is we regularly provide isolation solutions in the form of flexible isolators that work with products down into sort of the 30 nanogram levels of containment performance. And some of you have our isolator systems in your development areas and in your production areas already. So I've had the experience of working with flexible containment and where the benefits for that is. My presentation will go over some of those as well. And again, just formulating Onfab in a bit more details. That's our Middlewich facility and our US facility there. Actually, those labels are the wrong way round. So any eagle-eyed people will realize that this one here is in the US and this one here is in the UK. But what we are is that we have around 5,000 designs and 5,000 isolator systems that are in use globally. And we are very lucky at Onfab where we have isolator systems in every continent on this planet. And in Turkey, it has been a very fruitful market for us. And with Tema, we've developed quite a wide base of systems deployed in many different facilities in and around Turkey. Our manufacturing facility is ISO 9001 accredited, and majority of times we have been audited for many different types of manufacture, including even applications in the sterile areas where we take our flexible isolator range and we irradiate those enclosures so they can go into an aseptic approach. And as we are sort of known in the industry for very short lead times, so establishing a flexible isolator is a lot quicker than establishing a rigid isolator system, roughly around 10 weeks of delivery time from initial concept through to delivery and training of those systems. And then there is an ongoing development of replenishment through those systems, and we are able to supply those isolators much faster in a sort of 6 to 8 week period as well. Okay. These are some of our clients. As you can see, they are widing and they are full for many different types of applications, whether it be development or even through to full production in sort of biotech or through to oral solid dose. Predominantly, a lot of our isolator systems go into the oral solid dose manufacturing area, where we are supporting everything from dispensing right the way through to product packaging of the processes that you have in the facility. And as you can see, a lot of our clients here, I'll just touch on sort of the likes of AstraZeneca here, they deploy Onfab isolators around their globe in all of their development areas. It's one of the first clients that I ever worked with. And as I touched on before, there have been some further developments in Onfab's portfolio over the last few months. We're now part of an organization called Civilex. Civilex is a US manufacturer of PETG and PFA bottles. Okay, they use those in the biotech arena and have been doing that for a long period of time, fundamentally growing their life sciences business as they come through. And then very, very recently, we acquired a business called Optimum Processing as well, which provides single-use bag assemblies for the biotech industry. So we have a full range of isolation solutions where we have contained pretty much every piece of process equipment available in the market. But you can also see here that we have PETG bottles, PFA bottles, vials, and then we have various spin tubes, a Harvest Max, and Express Vent. But we are also able to support and manufacture, bespoke or product-specific bottling systems and also bag systems as well. Now, getting on to the subject matter of why I wanted to talk to you today, and again, just to reinforce some of those requirements around why containment technology is needed. Fundamentally, the market has developed very, very quickly, and there is now an increase in the use of highly active pharmaceutical ingredients within our sector. That can be led by a reclassification of those compounds. Now, that works both ways. They can be reclassified so they are now not considered potent, but also classified to be more potent as well. So those standard processes that you have in your manufacturing facilities already, you could then have a product that you've utilized for many years that has then been deemed to be more potent than the requirements that are there. On that basis, then we are able then to come into your facilities, take measurements of your processes and measurements of your process equipment, and add associated containment systems in the form of flexible isolators or other forms of containment systems to upgrade those processes so that they can handle those higher products moving forward. And then later on in this presentation, I'm just going to talk about our ADC system, so in our antibody drug conjugate system. Those systems are developing very quickly, and whether you want to start handling products that are down into the sort of nanogram levels and even into picogram levels of OELs, then we have facilities and the ability to do that now in flexible containment. We recently deployed an isolator in the US where we achieved 0.04 nanograms of containment performance. And that is a very, very low level, very, very high level of protection. Also, we have deployments, as we touched on, for product protection alongside our personal protection. So we are able to deploy systems where we are able to present and develop sort of GMP conditioning within the isolators, such as low humidity and low oxygen concentration inside those isolators as well. So fundamentally, where Onfab can assist you with your processing is anywhere where you need to control a product or restrict its migration from out of a manufacturing area itself. And this is done due to the hierarchy of control. I don't know if you've seen this picture before. This is in the recent DATCH release and the high containment guidance that has been released by the ISPE. Fundamentally, it is how you should build your containment strategy as you move forward. And there are other further readings that you can do with that, and those papers are available within the ISPE network. Just one thing to mention on them, and I don't know if there's any ISPE members here, but they do not shine flexible containment in a great light, and I am lobbying the ISPE to have a closer relationship with flexible manufacturers because it is a cost-effective, or fundamentally is a cost-effective way for you to achieve high levels of containment performance without having to build brand new facilities or placing really expensive rigid isolators into your manufacturing processes as well. Now, just running through some of the aspects of this hierarchy of control, the process is that you either eliminate the need to have the toxicological product in your process, or you substitute it. Now, those are both not possible in the manufacturing process. Now, this is where Onfab sits and other vendors that you're going to speak of today, where we have an implementation of engineering control. That's where you apply a solution to handle that hazard, to stop the migration of that product. In this instance, from Onfab, we are talking about flexible isolators. With ChargePoint, when you speak later, they're talking about valve technology. And then the next two steps are training of best practices. Now, one of those training methods can be staff rotation and managing their exposure limit to those products by limiting the actual time that they spend with the product. But fundamentally, the reason why I place this on here, the last of all is the placing of personal protective equipment. Now, personal protective equipment should be considered your last level of resort when it comes to handling high-potent materials. So it is okay to have people in respirators, but you should have already considered the rest of this process in line with your containment strategy and deployment of those protection factors that you need within your manufacturing process. Okay, so that makes sense that you shouldn't really rely upon PPE as the only way in which you're protecting your operators when you are handling high-potent materials. And now, just very quickly, I'm sure we're all aware of what a HPAPI is, but fundamentally, this is the scale. Let's go back one. This is the scale. This is the scale here that, again, is indicated into the ISPE. Recently, the band 6 categorization was placed in the band. It used to be a band 5, but what was happening was every molecule that we were protecting against was already in and above an OEB 5 level. Okay, so we were needing this extra level here to make sure that we were talking about the right protection factor and the right containment solutions that we need for our manufacturing processes. Now, anything from a 3 upwards should be considered to be high potent. Now, not all of these need isolators, because dependent upon the quantity of product that you have and the process that is in the process that you are deploying that product into always has a greater effect upon the potential exposure risk. Now, if you have an OEB3 molecule, maybe 100 micrograms per meter cubed, but you're handling a small quantity of that, you are very unlikely to have a risk pattern that may need an isolator. You may not need a negative pressure isolator. You may need to have a fume hood that you can utilize to handle that product. But anything from OEB4 upwards, you need to start considering the segregation of your operators from those manufacturing processes. And you can do that in many ways. You can either close loop that process, or you can place isolation systems in situ. I have seen many times where we've talked about different technology that provides an OEB5 level of protection, yet the operators have to take their hands out of that process, which have been in contact with the product, which would develop potential risks and associated risks with exposure and bringing that product out into the manufacturing space itself. I sort of sneaked my picture in before. Now, I don't know whether this is a good thing or a bad thing, but I'm a big Man United fan, so don't throw anything at me right now. Yesterday we beat Man City, so that's a good thing for Manchester United, especially with all the turmoil that we have recently in and around the club. But my special question is, I sort of give a representation of 1 microgram per meter cubed of a teaspoon of salt evenly distributed in an Olympic-sized swimming pool. So I was trying to think of not boring you with adding that question again. But my question is, how many grains of salt do you think the Manchester United stadium would manage to hold if you filled it up? Now, I think in some instances, the football that we play this year, it's probably a better use of this stadium by filling it with grains of salt. However, that's my question. There's also, we've been having a think about my answer, and we don't quite know if we have it right or not. There might be a factor or a scale factor that we might have out. However, there is a question there, and there is a prize associated with Manchester United for the lucky winner of that process. So if you want to scan this QR code and then answer the question, then please feel free to do so. And I'm going to say goodbye to Manchester United. So we touched on the various methods of how to handle HPAPIs, and I'm not going to just say that flexible containment is the only way to handle and have a strategy to handle HPAPIs. We touched on it before. We have personal protective equipment here. So this is your standard PAPR, power-assisted respirators that you can dress your operators up. This should be considered your last resort. We have our flexible isolator that you can see here on the display. We have our wonderful friends sat over in the corner over there, charge point valve, which is a closed transfer system. We have the ability to have screens in booths. And then at the very start, we have a rigid isolator system. Now, all of those methods are fundamentally a correct way to handle high potents. especially this one, and this one here, where you are completely segregating your operator from that process. Okay? So you are increasing that protection factor significantly. Now, when we do start handling HP APIs, that removement of the reliance of PPE is key. And what we talk about is that moving towards an engineering control. So that hierarchy that we showed on the last few slides, we start at the bottom and we build up. Okay, and one of the big things we think about is focusing upon containment at source. Now, I'm a big believer that you should relate the isolator into where the product is actually being used on a process. It's very simple to build a big isolator and push process equipment inside, but that leads to other issues such as increased cleaning time of the pieces of process equipment that you have, and you need to really target that containment to where the product goes. And then fundamentally, and one of the main things is to make sure that you have the right partner. Okay, Onfab has 7,500 designs for containment systems. The majority of those have been deployed in the market somewhere. That gives us the ability to very quickly get you into a position or get you examples of best practice and where those systems have worked and been deployed in the past. So making sure that you have that right partner with the right experience is really key to those applications as well. Now, one pretty bold statement that I give out in lots of times is that flexible isolators or flexible containment is really the only technology that can be deployed in all HP API handling scenarios. So by that, I mean we can deploy that from initial sampling in the warehouse through to dispensing, to milling, to granulation, to drying of the product. All of those processes can be contained through flexible containment. And all of those steps in those processes can be contained in flexible containment. Now, I have been shown many times in many facilities where they have a wonderful, high-potent manufacturing facility, and they have shown me around that manufacturing facility, and they have been very excited that they don't need any flexible containment. But they have missed fundamental areas such as sampling, such as even charging into a tablet press with product that would be susceptible to exposure in an operation process. That's what I mean when I say flexible containment is the only technology that can be deployed in each of those areas. Okay? It is, with those 7,500 designs that we do have a record of every single type of processing you can think of. And we have so many designs because there are different process requirements with the same equipment. So, I don't know, let's throw a couple of names out from people I've seen so far. So if Nobel have a milling machine and Abdi have the same milling machine, then they are going to use them in slightly different ways because the product requires slightly different manufacturing requirements. And we are able to build that into those processes so that it is easier and more ergonomic for the operators to deliver a process. And we are fundamentally aware that we need to maintain ergonomics because those processes are difficult to do. And that moves on to a couple of these benefits of flexible containment. And as I touched on before, some of you have already had flexible containment in your processes, simple standard processes like this, contained using Onfab's flexible isolators. And hopefully you have experienced some of these benefits as well. One thing I will spend some time on is just talking about the cost effectiveness of flexible isolators. So a flexible isolator solution to deploy a flexible isolator within your facility is approximately 10% of a similar rigid containment system that you would deploy in the same manner. Okay, we touched on the ergonomic challenges. So we try and work with your standard SOPs that you have so that you can maintain that process with that piece of equipment, but add a flexible isolator to it. And we all know that containment is going to be needed moving forward. That's why they need to be deployed in your current existing manufacturing processes to give you future-proofing for your products that you're going to manufacture in the not-so-distant future. Okay? And then fundamentally, these isolators need to be safe. We've touched on that hierarchy of control, and we've touched on the OELs that they can build. Now, I could spend all day talking about that, and Aileen just smiled at me then. She knows I can spend all day talking about that as well. But that safety factor is needed, and we can make sure that we are building systems that are safe for our operators to maintain those containment performances. Okay, a couple of things that I'm going to spend some time on, and I've got sort of 10 minutes left, I think, before lunch, so I don't want to lose any of you before lunch. But we've touched on the applications. Proven success in all of those pharma applications, in that oral solid dose, hormone, biopharm, and now this antibody drug conjugation. I'm going to talk where flexible containment has been and where it is going now moving forward. We've touched on supporting low humidity and how we can handle products that are susceptible to oxygen degradation, susceptible to many different requirements. And we haven't quite touched on air classification improvement, but we are now able to deploy isolators that have potentially up to a Class A environment internally as well, so that we can now have a flexible isolator that is A, gamma irradiated, but B, provides you the ability to VHP and have Class A air inside. Now, this is a picture from, I've worked at Onfab, or I've been part of Onfab for nearly 20 years. This is a very old isolator in an API production facility for reactor charging. It is fundamentally what flexible containment used to look like. There is nitrogen in and air out into the system. We use the airflow from the reactor to take the process, and we bring in via continuous liner, and we have waste out. Okay? The past is that they are simple ambient enclosures, probably protection to around 10 micrograms per meter cube, no better. They are simple structures. There's not really some ergonomic assessments in that. We have poor films and limited filtration. Okay? They're fundamentally deployed in what I would classify as dirty pharma, so API synthesis areas. And what we get now, and where we're moving to, is this type of isolator structure and these type of handling requirements, okay? This is our brand new ADC isolator. We have a range now of systems that are being deployed for nanogram and picogram levels of containment. This specific isolator was deployed in the UK, was deployed by a multinational pharma organization that was beginning their processes for handling ADC molecules. They had very limited protection in their manufacturing facility, and we deployed this isolator for them to handle ADC molecules. I will show you some of the results in the next slide. This isolator has multi-staged H14 HEPA-rated filtration. It has the need for pre-start pressure testing and has down into those picogram levels. Ergonomically, it can raise and lower, so the operators can sit or stand at the isolator system, and it is designed to have a fully disposable collapsation process so that you dispose of the flexible element after each single use. And the reasons for that is the quantities of product and the level of protection that we're requiring and the level of protection that is needed to validate that the space is clean is very difficult to do. So it is easier to dispose of that system than what it is to clean and validate that process. And as I said, this is the results from a surrogacy study around this type of isolator system. And this has demonstrated performance to less than 1 nanogram of containment performance. The ADC process predominantly has 2 isolators in tandem. We have a dry powder handling in this isolator, and we have wet handling in this isolator with the vessels. And we achieved across both of these isolators less than 1 nanogram. As you can see, lots of the processes there are less than 1 nanogram, including, and fundamentally, one of the hardest ones is the dismantling run in that system. So you can see that this provides the levels of protection needed to handle an OEL, which is way below. We have just had results on Friday for another isolator that we had, and that was 0.04 nanograms of containment performance. It looks very similar. It's a negative pressure isolator supported by a structure, but there are processes that are developed in that are needed to be adhered to make sure that you maintain that containment performance moving forward. Okay? So this isolator allows us, it may not need to be deployed in an ADC application. It can be in for a powder handling application. But this will give you levels of protection down into those nanogram levels. And that's where I'm going to leave this presentation, just on that last point around the points of containment that we have and the levels that we can get down to. I touched on before that the ISPE guide that has recently been released still demonstrates that flexible isolation is only good for 0.1 micrograms, which is 100 nanograms. But this technology, with organizations that are reputable in that space, can achieve these levels of containment performance. So it is fundamentally a very good, cost-effective way to getting you high-potent ready very quickly. Some of my contact details here. If anybody wants to take a photo of them or anything to get in contact, or better still, reach out to Tema for all of those requirements needed. I'm around for a few more hours today, so if anybody has any questions, I'm sort of sat over in the corner over there, but feel free to come and have a conversation with me around your containment needs moving forward. And hopefully you will have a good dinner, lunch.